In this video we will see rectilinear motion and curvilinear motion. The first case is body is moving with a constant acceleration, which is a is constant. Here this body is moving with acceleration a, its initial velocity is u and final velocity is v. Now it travels the distance s in time t, so this is the distance s. Now here three equations are used, which is v is equal to u plus at. Final velocity is equal to initial velocity plus acceleration into time taken to travel that distance. Here acceleration is constant, which is important point. Here s is a distance traveled, which will be equal to ut plus half into a into t square. So this is how we can calculate distance traveled with initial velocity, acceleration and time. The third equation is, this equation does not include time, so if we have relation between initial and final velocities, acceleration and distance travel, so it's v square minus u square equal to 2 into a into s. So these three equations are used to solve the problems of constant acceleration where body is moving in straight direction, straight line. Now if the body is moving continuously, so the v, s and acceleration, these three are given as a function of time, then we have to use these differential equations where velocity will be ds by dt, acceleration will be equal to dv by dt. Here it simply means change in distance upon change in time for v, and for acceleration is change in velocity upon change in time. And the third equation we can derive from these two is, if we multiply dv by dt with ds on the denominator and numerator both, then this ds by dt will be equal to v, so v into dv by ds. So if velocity is a function of distance, then we can use this equation for calculating acceleration. So these three equations are used for continuous motion where functions of time is given for all the variables. Now from this time variable, if we plot s versus t, so this blue color line are three functions, vt diagram and at diagram. If these three diagrams are given or any one of them is given, we can find other properties. Like in st diagram, if we take the slope, so v is equal to ds by dt, this is the slope ds by dt, which will be equal to the velocity at that particular point. So here if you see, slope is decreasing, so velocity will be decreasing with time. Here this blue color line is the velocity versus time line, and the area under the curve for t1 to time, this is the t1 time from here t1. So t1 to t2, if we take t1 to t2 area with this graph, we get the area equal to distance traveled. Integration t1 to t2 v dt will be distance traveled, and the slope of this curve will give the acceleration. dv by dt is the acceleration. And in at diagram, if we take the area under the curve, we will get the velocity, because integration a dt from t1 to t2 will give the area, which is velocity of this diagram. Now in curvilinear motion, means body is not moving in a straight line, it is moving in a curve. So here we have x and y coordinate, and the distance travel is x and y in two different directions. Velocity is u in v in x direction and y direction, and acceleration in x direction is ax and acceleration in y direction is ay. So if we want to calculate the magnitude, we have to simply use this formula, which magnitude of s will be equal to under root of x square plus y square. Similarly for v and acceleration. So these three component we have to use with the standard equations, and we have to solve this x, u and v with these three formulas. We have to apply all these above equations separately in x direction and y direction, and then we have to use this 3 to find the magnitude. So here this in x direction, we have to solve this entire particular thing separately, like final velocity in x direction equal to initial velocity in x direction plus acceleration in x direction into time. Similarly, distance traveled in x direction will be equal to velocity in initial velocity in x direction, and here acceleration will be ax. Similarly, we have to use all the formula, final velocity in x direction, which is small v, and minus initial velocity in x direction, which will be some ux, and equal to 2 times acceleration in x direction and distance travel in x direction, which is here x. Similarly, we have to use for y direction, and this is how we have to calculate for both this direction. in curvilinear motion, and then we have to find the magnitude. So in this video we have seen rectilinear and curvilinear motion. We will see projectile motion in the next video, which is a part of curvilinear motion, and then we will see some angular motion. So thank you for watching this video. Do subscribe and share this video, and see you in the next video. Thank you guys.